In question 9, we are looking at sectors and trigonometry, and the first thing to notice is that the information we are provided gives us with the angles in radians. So you're going to need to make sure that you've got your calculator set in radians, otherwise you'll get some odd answers. So we have been given a situation where we've got a circle of centre O with a radius of 4. We are also told that angle ADC is 0.3 and angle AOC is 0.8, and we are asked to find AD. So if you note that we have got a side and an angle opposite, and with the side AD we have got the angle opposite it. So we've got these kind of two pairs here, so we're going to be using the sine rule. We want to have the unknown at the top. It just makes it slightly easier. So if we have AD over sine 0.8, we know that that will be the same ratio as the other pair we have, which is AO, which is 4 over sine 0.3. So we can just rearrange that to give us AD is going to be equal to 4 over sine 0.3 multiplied by sine 0.8, and that will give us an answer of 9.71. For part B, we are asked to find OD, which is going to be this length here. Now you'll notice, so obviously we've still got the same ratio that we had in part A, so we know that we've got 4 over sine 0.3. But if we want to find OD, we are going to need the corresponding angle. Now at the moment we don't have the angle there, but fortunately because we've got the two angles, we can calculate it. So angle DAO is going to be the sum of the angles in a triangle in radians, which is going to be pi minus 0.3 and 0.8, which is going to be 1.1. So the angle is going to be, we want to find the sine of the angle, which is going to be 2.04. So again, we can just rearrange that. So therefore, OD is going to be 4 over sine 0.3 multiplied by sine 2.04, and that is going to give us an answer of 12.1. In part C, we're asked to find the area of the sector OABC, which is this area here. So if that, we're just going to use the formula for the area of the sector, which is area equals theta r squared over 2, where theta is in radians. So we've got the angle in radians, so we can just work out that that is going to be 0.8 times 4 squared over 2, which is going to give us an area of 6.4 centimetres squared. In part D, you're asked to find the area of region ABCD, which is the region highlighted green here. Now, the easiest way to do this is actually to find the area of this triangle, and then from that we can subtract the yellow area, which we already worked out here. So in order to calculate the area of the triangle, we're going to want to use the formula for the trig area of a triangle, which is half AB sine C. So there's a number of different ways that we can use this, but let's use this angle here as our angle C. So we'll have half times A, which is going to be 4, multiplied by B, which is going to be our length DO, which we found out previously was 12.1. So we can have half times 4 times 12.1 times sine 0.8 in radians, which is going to give us an area for the triangle of 17.32. So if we then subtract the yellow area which we had, which was 6.4, the area shaded green will then be 10.9 centimetres squared.